Stability. As illustrated by the figure 3, a body is said to be in a stable equilibrium position if, when displaced, it returns to its equilibrium position. Conversely, it is in an unstable equilibrium position if, when displaced even slightly, it moves to a new equilibrium position. Stability considerations are particularly important for submerged or floating bodies, since the centers of buoyancy and gravity do not necessarily coincide. This is the simplest example of stability. So if you have a curved surface like this, and then you have a ball located at this one, if you give this ball an external force, so this ball will move like this. So, however, at the end of the movement, so you will find that this ball will remain on its original position. So means the device here is stable because this object capable to remain in its original position after you apply an external force. So however, if we have a curved surface like this one, but and then we have a ball here, so if you give this ball a very slight force, so you will find that this ball will move and then it will not return to its original position. So means that this setting or this design is not stable. A small rotation can result in either a restoring or overturning couple. For example, for the completely submerged body shown in figure 4, which has a center of gravity below the center of buoyancy, a rotation from its equilibrium position will create a restoring couple formed by the weight W and the buoyant force Fb, which cause the body to rotate back to its original position. Thus, for this configuration, the body is stable. It is to be noted that as long as the center of gravity falls below the center of buoyancy, this will always be true. That's it. The body is in a stable equilibrium position with respect to small rotation. So this is the example of the stable body. So if we found that the center of gravity is below the center of buoyancy here, so it will create a restoring couple. So restoring couple means it's capable to restore itself to the original position. However, as is illustrated in figure 5, if the center of gravity of the completely submerged body is above the center of buoyancy, the resulting couple formed by the weight and the buoyant force will cause the body to overturn and move to a new equilibrium position. Thus, a completely submerged body with its center of gravity above its center of buoyancy is in an unstable equilibrium position. So this is the example of previous explained phenomenon. So if the center of gravity is above the center of buoyancy, so it will create overturning couple, which make this object cannot come back or cannot remain to its original position. The floating bodies, the stability problem is more complicated, seen as the body rotates, the location of center of buoyancy which passes through the centroid of the displaced volume may change. As is shown in figure 6, a floating body such as a barge that rides low in the water can be stable, even though the center of gravity lies above the center of buoyancy. This is true since as the body rotates, the buoyant force Fb shifts to pass through the centroid of the newly formed displaced volume, and, as illustrated, combined with the weight to form a couple which will cause the body to return to its original equilibrium position. So in this statement, we are focusing on floating bodies. In floating bodies, it looks like this because not all the bodies here will submerge in the water. So for this situation, so we will find that center of gravity is actually above the center of buoyancy of this one. So and then if at certain position, so if we give this object or this system an external force, so it will incline like this one. So and then the center of buoyancy will change. You need to remember that center of buoyancy is actually the centroid for the submerged area only. So at here, so this is the center point for the submerged area. So the centroid. However, when it's inclined a little bit like this, so the center of buoyancy, okay, will remain in this, will change to this position because it is to divide these two areas into the equal area. So that's why the center of buoyancy will change according to the volume of the displaced, according to the displaced volume. So for floating object like this one, if the center of gravity is above the force of buoyancy, center of buoyancy, so it will create restoring couple, which could make the object to come back to its original position. However, for the relatively tall, slender body shown in figure 7, a small rotation displacement can cause the buoyant force and the weight to form an overturning couple as illustrated. However, not all floating body will have a restoring couple. For example, if you have a slender body like this one, the center of gravity here is above this center of buoyancy. Same with the previous condition like this one, but it will create an overturning couple, which means that this situation is not stable. So it is mean that it is not easy to determine whether that object or that system is stable or not by only looking the center of gravity and center of buoyancy. Means that we need to develop an equation or a method to determine the stability of a floating object. So this is one example for the stability. So I think everybody could imagine this punching box for kids, for example. So normally we will put a small amount of water under this object. So it will create the center of gravity on this area. So it means that every time you give an external force, so every time you punch this toy, so it will move and then it could back to its original position. So it will keep standing vertical like this one. So this is the simple application of stability.